Primitive obsession code smell. What is a code smell first? Characteristic in the source code that indicates some deeper problems or maybe negatively impacts implementation design or creates some troubles now or in the future. Could smell a little bit at the beginning, but then when the code enhances, the smell could be more powerful and create more trouble. Primitive obsession code smell belongs to bloaters group. They kind of do not appear right away, they accumulate over time. And normally when nobody makes an effort to eradicate them. Small smell and then more and more troubles it brings. So let's get down directly to the theoretical examples. We have here a user class. Probably there is something wrong with this code. You can see that it has the email field, and the email field behavior is also implemented within this class. So user kind of knows how to check whether email is valid or no, and only then sets it on his own. Code that I just demonstrated clearly says a symptom of the primitive obsession. For email, we are using string, a very primitive type, which is not an object, not an array, not something more complex, but just a pure string, very primitive type in JavaScript or in any other language. Within some time, if this smell appears, the code gets extended. Code will come up to negative consequences. For example, when you decide to enhance some consumer with another field, then this consumer might have another logic for this field, if you pick a primitive type for that field. Or in a web code base, it's a very big negative consequences. We are creating a business logic functions that belongs to some widely used objects or widely used types within a feature model. Consumer creates how to validate this object and so forth, directly how I shown on the user example. I want to point attention to the trouble code smell or these consequences afterward creates. So consumer grows unmanageably within time. Our user could grow a lot if you add different primitive types into that and manage their business logic within the user. Or primitives tie their business logic to the consumer, that violates a single responsibility, and code becomes less flexible, harder to control, harder to reuse. Developer can't easily find such a business logic to reuse if this business logic is tied to a consumer, in our case an example is user. If we look at every of these troubles on the code, when email business logic expands there, let's say we implement some distinguishing between corporate email or private email, then user will grow. Or the primitives, when they are tied to a business logic like there and we add a, let's say, address, as a user handles all this stuff. The user will know where the street is stored, where the city shall be stored in this primitive array. Probably a user doesn't have to know about all this. User kind of grows unmanageably. If we look at the third trouble that I list here, code becomes less flexible and hard to control. The user is kind of very flexible, it handles everything it could, you know. It knows about implementation details of an email, how email is validated, or about the address, how it's being set. And to change this business logic, let's say to change an email validation or so, we always need to touch the user. To change the email, to change the address, it's all the same, we are touching the user. Single responsibility principle says always that the class or a service shall have one reason to change, right? And our user has many reasons to change, not only that it's somehow user related, it's also related to address. When address changes, some logic changes, well, we change the user. It's hard to control such a code and it's hard to test. And how to reuse such a business logic is not easy. You will need to import the user into another consumer that needs just email validation, and all your user will go along, unnecessary, creating a dependency. And it will look like this maybe. Regarding the last trouble, it's kind of important, is a mess, it's hard. And now how about to fix troubles? Martin Fowler in his book lists all the treatments to avoid troubles with primitive obsession. The one that I want to look together is replace primitive type with object. Let's say we have a user and it shall have an email, and we abstract an email into separate class which handles all the business logic related to this object. And even it has not only setters, getters and so, but it also has this validation which belongs now to an email. This gives a lot of benefits. Object type declarations. Methods will be accessible through type hitting in your IDE. So as soon as you deal with email, well, you could find the methods it holds and use them and learn about them. You can also reuse email now by different consumers, not only having it within user, but also employ it to any other consumer that deals with email. Maybe it's not an user, maybe it's something else. So you could import it and you don't carry the user along, which is awesome. And the most important business logic belongs to the email. This creates a single responsibility because the email class has now one reason to change. Today I wish to talk about negative consequences of the primitive obsession code smell. Let's look at negative consequences through a prism of web development. And in web development we mostly don't use classes. Even examples that I just shown are in classes. I wanted to give an impression that in different languages we have different setups. And in JavaScript it's not popular actually to use classes. Instead we use anonymous typed objects. We use Typescript that helps us at least to describe the type. And what does it mean, the anonymous type object? Let's say in our codebase, we create such a payment variable. We mark with a certain type or interface, and then Typescript helps us to figure out what this object is about. This is very good because it helps you to know what kind of properties the object can contain, their types, and so forth. I'm sure in other programming languages you have static typing as well. Or let's say in transaction interface we have this sender and receiver address, and they are defined as array of strings. How to figure out what is city, street and country? You can only by knowing the domain. Otherwise, if you look at this code first time or just open a file with that, you won't be able to know. One of the consumers, which is related to card delivery, has an address which is set up much better. With this setup, in a TypeScript code with static typing, you can clearly know that the address of the card delivery has city, country, street, and other properties. Amount, almost good, kind of value, precision, currency. Maybe currency could be another object, which could store the abbreviation of the currency and symbol of the currency, but string is also fine. So email, address, amount, phone number, all are a kind of domain objects, and they are used by many feature models. And we also have George core domain objects, account, transaction, payment order, contact. There are so many, I think more than a dozen of such a core domain objects people are operating with. Since in JavaScript, as I mentioned, we didn't use classes, it's very hard to tie business logic to anonymous typed object. So you cannot implement methods there or something related to directly amount or payment order or email or so. And I want to show an examples how we handle this now. So we have payment forms. This is where most of the work happens. It deals with different stuff regarding to payment. And you know, we just created such a helping functions that get us some information from an account. So payment model can query the amount. It knows how to get the balance. Payment model is brave enough to create an amount on its own. Moreover, payment form feature model knows how to check whether the amount has a local currency or no. All implementation details payment form knows. And it extends as soon as we add more and more of such a methods that actually deal with core domain objects. Or payment form can identify whether IBAN is valid or no. It's all payment form. The problem is that all these stuff that I mentioned and dozens of stuff beyond that is also necessary by other feature models. And if some other feature models wants to reuse it, they will carry the payment form along. This is not a good idea, because it will create direct dependency between feature models. And this is expensive to reuse such small methods this way. If payment form wants to take something from standing orders, it will take the whole standing orders or a lot of standing orders along. And we wish to avoid this because we want to ship features in models, we want to ship them separately. Because maybe we want to embed some features into mobile. And now to do this, we need to boot the whole George. Other solutions how developers handle that is that they re-implement the same logic that I just demonstrated, copy the same in address book or in transactions, how to query the balance from account or how to identify whether IBAN is valid or so. Well, this is much better than importing the whole payment form along, right? But we end up with a lot of duplicate code this way. The same business logic for a core domain objects or for George core domain objects are done in multiple feature models. As soon as this core domain object business logic grows, the model grows along. I just demonstrated at the beginning with user class how it can grow if you put inside receiver address, if you put inside email logic, and so forth. So your consumer grows. But why if we are dealing with core domain object? Now let's try to solve interdependencies. First, we need to identify core domain objects. These are address, amount, currency, date, phone number, and many others. The second step is to create a service or a class for each core domain object. We need to ensure that this service or a class has interface that describes the object and obviously has some I/O methods that handle business logic. A class like this, you have an amount and there are some properties, which is an interface. Then there are these methods within this class that manage pure business logic of this object. Or let's say we have an IBAN class, some type for IBAN, and some methods that deal with the IBAN. Checks whether IBAN is valid, checks whether it's domestic, for example. Or if we talk about a web environment where we don't use classes, there will be a service which will have this implementation of the interface and all the service methods that deals with one object. There won't be any context of your feature model inside. This way, when we have such a service or such a class, obviously our dependencies are not anymore interconnected. Everyone is using just IBAN service. You don't carry along other feature model when you want to use something related to IBAN. This kind of simplifies a lot. And there are a lot of benefits having core domain objects. For example, domain objects manipulations are within one service. Operations are not scattered anymore. Business logic belongs to the object it operates on. And when this business logic extends, who will grow? Not a consumer. The service or a class will grow. Object manipulations can be now reused. In the long run, such a separation and investment to split this stuff into core domain objects will pay off because the reusability will be very good and the knowledge will be shared. So as soon as you want to look what IBAN can do, you open one file and there you can explore what IBAN can do. This gives you as a developer awareness, and this way the code will become cleaner in your feature models.